Hello and welcome to the Visual Studio 2010 Coded UI Test Automation webinar. My name is Ian Holdsworth and I'm a consultant with TestHouse, the independent software testing specialists. We are an award-winning software testing consultancy and also a Microsoft partner with offices in London, Madrid and Kerala, as well as the United States, Dubai and Saudi Arabia. We offer test guidance and process improvement as well as test management, manual and automated testing, application lifecycle management support from Agile all the way to CMMI. We support both functional and non-functional testing, such as load testing, and are dedicated to process improvement using Visual Studio 2010 Team Foundation Server. Here we have a subset of our clients in the Middle East. Microsoft Visual Studio 2010 is a multifaceted development platform comprising not only support for Microsoft Team Foundation Server, but also Microsoft Test Manager, lab management, unit testing, performance and load testing, as well as many others. Over the next few months, TestHouse will be presenting a series of training sessions and webinars on many of these aspects. Today I am primarily going to be concentrating on coded UI test automation. So why automate testing? Well, as I'm sure anyone with any experience of manual testing will tell you, manual testing is laborious, time-consuming and expensive. It is difficult to implement consistently when not even the best manual tester in the world can precisely duplicate the same test twice with absolute precision. By automating this tedious activity, not only can the test be repeated as often as wanted, but it can also be incorporated into team build as well as so that tests can be run overnight or even as part of your build verification test to enable you to determine straight away when the tested functionality has been broken. Utilizing a test framework, multiple tests can be modularized and controlled and configured with something as simple as a CSV file, placing the command and control of automated tests firmly in the hands of anyone who can use Excel. So what are coded UI tests? Well, in essence, coded UI tests are relatively simple programs. Supported platforms are C#, C++, and VB.NET. They rely on multiple technologies, from legacy Microsoft Active Accessibility components to user interface automation. Browser support for Internet Explorer and Firefox 3 comes out of the box through extensibility support. So how do we implement them? They can be implemented straight out of the existing manual test cases, either from an existing action recording or a manual recording. They can be data driven so that the same test can be run against tens, even hundreds of scenarios. They can be incorporated into your build verification tests, even into your continuous integration builds, although I recommend that this is only done for the fastest tests, giving you a full range of regression tests. Okay, so what I'm going to demonstrate today is a simple coded UI test of the Calculator app, which comes with every version of Microsoft Windows. I'm then going to data drive that test, and finally I'm going to demonstrate the new coded UI test editor. The basis of all coded UI testing and recording is verification and playback. Is recording, verification and playback. I'll now load the virtual machine I'm going to run this demonstration on. Incidentally, if you want to download this virtual machine in order to familiarize yourself with the coded UI or any other aspect of Visual Studio, it can be downloaded for free from MSDN. Okay, so first I'm going to start Visual Studio. I'm then going to go to the Test menu, select New Test, and then select Coded UI Test and rename it to Calc Project. I'm going to set the Add to Test project to Create New Visual C# Test Project and click OK. I'm going to set the name of the project again to Calc Project. And hit the Create button. I'll now be asked if I'd like to record a set of actions from scratch or generate the coded UI test from an existing action recording. In this instance, I'm going to record a set of actions from scratch. So I'm therefore going to select the Record Actions, Edit UI Map or Add Assertions option and click OK. Notice that Visual Studio has minimized and that we are now presented with the UI Map Coded UI Test Builder. This has 4 buttons: the Record button, the Show Recorded Steps button, the Crosshair or Add Assertion button, and the Generate Code button. These allow us to record interactions with any part of the user interface. Note that the Crosshair button also allows us not only to add assertions but also to pull data from any other part of the user interface for validation and reporting purposes. I'm going to press the Record button and I'm going to go to the Start menu, All Programs, Accessories, and I'm going to select the Calculator application. You will note that tooltips appear above the Coded UI Test Builder as I'm recording these actions. I'm now going to press Pause and select the Show Recorded Steps button. Notice that all of these actions that are recorded have now been consolidated into one simple action. This is what Microsoft calls intent-aware recording, the ability of the recorder to consolidate several steps into one logical step where necessary. Now, let's press Generate Code and rename the method to Launch Calc. And hit the Add and Generate button. This is now generating the method into Visual Studio. Now I'm going to press Record again, hit the Cancel button on the calculator, and then hit 2 plus 2 equals. Note the tooltips again on the UI above the UI map generator. Now I'm going to pause again and show recorded steps. Note that at any time, if we want to delete a particular step that has been recorded, we can simply select it and press the del key, or we can right click and select delete. In this instance, I'm going to press Generate Code and I'm going to rename the method to DoMaths. Now we need to verify that the calculation worked correctly. In order to do this, I'm going to drag and drop the crosshair control over the result control in the calculator. You will notice the blue highlight that this control is given. We are now presented with a property sheet. This presents us with all the accessible properties within that control. Be aware that the control selected by dropping the crosshair control is not necessarily the one we wanted. This is because multiple controls can occupy the same area on a window. You also have some controls which are children of others. In order to enable you to select these controls, the property sheet has a set of arrow keys next to the refresh button which enable you to navigate from parent to child and to sibling records. Also on the property sheet there is an expand button which exposes more details and enables adding of a control to the UI map, deleting controls, renaming and copying a reference to the clipboard. When we have the control selected that we want, we select the appropriate property that we wish to verify. In this instance, the display text property would be our starting point. We then select Add Assertion. We're now presented with the Add Assertions window. You'll notice that the comparator option, drop-down box, has got all the options we are likely to need. In this instance, we're going to select R equal and leave the comparison value at 4. I will then click the Generate Code button again and rename this method CheckMaths. I will then click the Record button again, and this time I'm simply going to close the calculator. Hit the Generate Code button, and I'm going to call this method Close Calc. Now we close the Coded UI test builder. If we inspect the code in our Coded UI test method 1 method, we should see all the methods that we have recorded. Our launch calculator method, the do maths method, check maths, and close calc. Note that we can modify the code in our calcproject.cs file and also in our uimap.cs file. However, the code in the uimapdesigner.cs file is generated every time we use the Coded UI test builder. So therefore you should never change the code in that particular module, but you can change it in the uimap.cs file and in your calc project or your main project CS file. Now if we build and run our project, it should load the calculator, perform the mathematics, verify the result, and then close the calculator. We're just waiting whilst it continues to build the project. Here we go. Cancelled it, done the maths, hit equals. And if we now view our test results, we can see that the test passed. Customizing a Coded UI test is quite simple, especially with the new Coded UI test editor released in Feature Pack 2, as well as the Coded UI test builder. We can data drive a Coded UI test from any data source supported by the .NET framework. Now that we have a working, if slightly simple, Coded UI test, let's make it a little more complicated. First, I'm going to create a CSV file with 3 columns. The first 2 columns being 2 numbers which will be added together, and the third column being the expected result. And in the finest traditions of any demonstration, here's one that I prepared earlier. Next, I'm going to select the test menu in Visual Studio. I'm going to select the Windows option, and I'm going to select Test View. I'm then going to navigate from Solution Explorer, if that's where I am, to Test View. I'm going to scroll up in the Properties window beneath it, select Data Connection String, and then select the ellipses button next to it. I'm then going to select CSV file, because we're working on a CSV data source. Select the next button. Next to the Choose File field, I'm going to click on the ellipses button, and I'm going to select my sample data. Here we see the sample data with its 3 columns, number 1, 2 and expected result. I'm going to click the Finish button. I'm now being asked if I'd like to copy the database into the current project. I'm going to select Yes. You will now note that the coded UI test method, the test method attribute now has the additional deployment method, deployment item, and data source attributes. Also be aware in Solution Explorer that the CSV file has now been copied into our solution. If we need to make any changes to this CSV file, we need to change it from our solution folder and not from the original folder. Also note that wherever our test is deployed, this file will be deployed with it. Next, we need to add the following code before our doMaths method. I'm going to take that, and I'm just going to copy and paste some that I prepared earlier. As you can see, what we're doing is we're taking the property that we are writing to the user interface, and we are setting it to the first column of our test context. We are then doing exactly the same for the second property that we are writing to our user interface with the second column. And now we need to add an additional piece of code before our check maths, because we need to pick up the expected result column. Again, we are taking the property and we are setting it to the test context. Now, as we can see, we are setting the properties to our 2 numbers and the property for our expected response, all from the data source. This will now be run through for each of our records in the data source. If I now run the selected test, as we can see, the test is running through each iteration of our CSV file until it gets to a rounding error, which won't be quite yet. There we go. Now, it may well be the case that we wanted to catch said rounding error. It does represent a valid error. However, in this case, we don't need to be quite so precise. So I'm going to stop the debugger. On examining our UI map designer.cs, I can see the method that I want to modify is the checkMaths method. However, I know that any changes I make in the UI map designer file will be overwritten next time I use the coded UI map test builder. What I'm going to do is I'm going to move the checkMaths method from the uimap.designer file to the uimap.cs file. The way I'm going to achieve this is I'm going to use the UI map test editor, or the coded UI test editor if you prefer. I simply right click in Solution Explorer, select the uimap.ui test file, and select Open. Note that if you are yourself presented with an XML file then you have not installed Feature Pack 2, and you will not be able to continue with this part. I am now presented with the coded UI test editor. This enables us to find, delete, rename, adjust the properties of, split into a new method, move to a uimap.cs file, insert a delay before, locate a UI control, or locate all the UI controls. I have selected the checkMaths method and click the Move To button. I'm now asked if I want to move this method, as once it is moved I can no longer edit it using the coded UI toolset. To edit it, I am restricted to changing the code by hand. In this instance, this is exactly what I wish to do. So I select Yes. Note that the checkMaths method has now disappeared from the coded UI test editor. I'm now going to close the UI test editor and save the changes. If I now go to my uimap.cs file, I can see that my checkMaths function and all the related functionality have now been moved into the uimap.cs file. We can now edit this to our heart's content. In this instance, we want to reduce the precision of which the calculation is being compared at. In this instance, we are going to actually just compare it as a simple floating point, not as a double floating point. One easy way is to recast the strings as floats. So let's add the following 2 lines of code. Float number 1. So I'm going to create my float variable, and I'm going to set it to system convert single, and I'm going to take my string method, my string property from the check maths expected values and the display text property. I'm then going to take my floating point number 2 and set that again to system convert, again to single, to the UI item zero text dot display text property, and modify the assert are equal line to equal number 1 and number 2. If we now run our test, I've got build errors, sorry about that. I think I know what I did wrong. Yeah, there we go. See, nothing ever goes to plan. And let's just insert a blank line there. Right. We now build and run our test. We should see that after it's completed building, our test should run through an iteration of every row in our CSV file and should now pass when it reaches the floating point issue. Here we go. And hey presto, it would appear, if we set the test results down at the bottom, that the test has passed. If I right click on that and select View Test Result Details, we are now presented with the duration and the status of each row within the CSV file. Which can be useful for testing for performance issues. Moving on, I'm not actually going to be demonstrating coded UI workflows today. However, it is a natural follow-on from data driving a coded UI test, as the data provided does not actually have to be specific to a coded UI test. It could be a list of coded UI tests, or even a list of search parameters to identify controls and actions to perform on those controls. However, that is definitely the topic for another day. We have also included some additional resources, which include numerous hands-on labs, a downloadable virtual machine, and Matthew Einion's content index for coded UI tests. Thank you. For further information on upcoming training, please visit our microsite www.th-ms.com or contact Shalu. This concludes the demo. If you have any questions, I'd be more than happy to answer them.